All right, here we go. Day number 4, notes in chapter 6 of algebra. This is a quick review day of solving inequalities and graphing inequalities on a number line. So I'm going to run through this a little bit quicker. Please pause and go back if necessary. But in this problem here, I am going to first distribute on the left side. When I distribute on the left side, I'm going to recognize that I have p's on both the left and the right, so I'm going to want to add to get the p's on the same side, so I'm going to add 2p. But when in fact I do this, the variables drop out. Well, I need to take a look at this and say, if I were to look at negative 12 is less than or equal to 8, is negative 12, which is a negative number, smaller than the number 8? And we say, why, in fact, that is a true statement. What that means is that it is always true. Doesn't matter what number I put in here for the letter P. So we end up with all real solutions, meaning that anything I put in there for P would make this inequality true. How do I graph this? Well, I'm going to recognize where 0 is, and I'm going to highlight and shade every number on the number line. I'm going to also include those arrows to show that these numbers that continue on to the right and these numbers that continue on to the left, meaning like numbers like negative 50, negative 1,000, positive 2 million, any number that I'd pick would work. Problem number 2 is a compound inequality. Here I'm going to remind us to graph both inequalities. This is an OR statement, so we need to graph both inequalities. I'm going to solve the one on the left first. So I'm going to add 5 to both sides. I'm going to get a is greater than or equal to 4. I'm going to also solve this one over here. I'm going to divide by 3. I'm going to get a is less than negative 8. I'm going to write the inequality where I have a as both being larger than 4 or a is allowed to be less than negative 8. If I need to fit this on my number line, I am in fact going to count by 2's just to make sure that I can fit it all in. And I'm going to graph the blue one in blue, and I'll graph the red inequality in red. So here we get a is greater than or equal to 4. We're going to be closed at 4 and shading to the right. We would like all those numbers that are larger than negative 4, or we would like the ones that are less than 8 open at 8 and shaded to the left. Again, that is what we talk about a compound inequality, which is an OR statement. In problem number 3, as I read problem number 3, this is read as negative 27 is less than 9m, and, so we're going to make a note here that this is an and, 9m is less than or equal to negative 18. Well, when I like to solve this, I'm going to remind myself this is a compound inequality. When I solve it, I do need to make sure that what I do to the left, I also do to the right. So I'm going to divide by 9m in the left, the middle, and the right. As I do so, I'm going to get negative 3 is less than m, which is less than or equal to negative 2. So this is read, negative 3 is less than m, and m is less than or equal to negative 2. I like to remind myself that in an and statement, we're going to be graphing the intersection of these, or if I recognize where m is located here, I'm going to be graphing those values that are between negative 2 and 3. So this is an open circle at 3. This is a closed circle at negative 2. And then I'm graphing these values in between. So I got to do a quick little squiggle there to recognize those. In problem number 4, this is an OR. So remember, in an OR statement, we're going to graph both inequalities. Again, I'm going to solve the one on the left first. I'm going to subtract 2. I get 5n is greater than negative 20. I'm going to divide by 5. and I'm going to get n is greater than negative 4. I do not need to flip this inequality sign here because I divided by a positive 5. In problem number 4, the second inequality, I'm going to distribute. I'm going to get negative 3n. Negative 3 times positive 4 is negative 12 is greater than 21. I'm going to grab that negative 12 or subtracting 12, and the inverse is to add 12 to both sides. So I get negative 3n is greater than 33. I'm going to divide by negative 3. And I'm going to get n is, we need to remind ourselves here that if we divide by a negative, we do need to flip this inequality sign. So here we're going to get n is less than negative 11. I'm going to write this all out below as one statement where we say n is greater than negative 4 or n is less than negative 11. Remember, in an or statement, we said we're going to graph both of these. I'm going to put 0 way over here. I think I can fit this in. We'll see. Negative 1, negative 2, negative 3, negative 4. Ooh, look at that. Squeeze it just in there. Because we need to graph here. The blue says n is greater than negative 4. Here is negative 4. All the items that are larger than negative 4 are all these numbers to the right, moving towards the positive values. When I would like to graph the red one is going to say n is less than negative 11. So here is negative 11, and all those numbers that are less than negative 11 are all these numbers over here that are moving to become more negative, or if we think about that on a number line perspective, smaller. Number 5 here, this is another and statement where we do have to realize that we have 3 sections here. We have a left, a middle, and a right. And if I'd like to solve this here, we're going to work to get the negative 2t, the variable that's in the middle of these two inequalities, by itself. So the first thing I'm going to do is subtract 2. I get negative 12 is less than or equal to negative 2t, which is less than or equal to 6. I'm going to divide by negative 2. And again, I'm going to make a big note of this here, that if we divide by a negative, we need to flip not only that inequality, we also need to flip this other inequality. So if this was a less than or equal to, this will now become a greater than or equal to. And likewise, this here is also greater than or equal to. If I go through the solving here, negative 12 divided by negative 2 is positive 6. Negative 2 divided by negative 2t divided by negative 2 is 1t. And 6 divided by negative 2 is negative 3. We can recognize here that x, or in this case the variable t, is located between 6 and negative 3. So as I get ready to graph this here, where we are going to be graphing 6 is greater than or equal to t, so here is 6. T is greater than or equal to negative 3, so here is negative 3. Both those endpoints are included in the solutions because both of them were equal to, and then we can shade all the possible values in between. Again, we talked about this the other day in notes. If you would like, you can also write this with the small number being on the left, saying it's less than or equal to t, which is less than or equal to 6. Again, this is that's up to your preference if you'd like to write that. Sometimes people like that because here's negative 3 on the left, here's 6 on the right, and then here are all the possible t values in the middle. That's up to you. All right, last example here on this page. We're going to solve this one here. We're going to subtract 6 on both sides. We get 1/3 times x is greater than or equal to negative 4. Remember, if you are multiplying by 1/3 and I'd like to get x by itself, what we're going to do here is we're going to multiply by what is called the reciprocal. When you multiply by the reciprocal, 3 times 1/3 is going to become 1x is greater than or equal to, this is -4 times 3 over 1, or -4 times 3, which is -12. So we are graphing here x is greater than -12. Again, I did not need to worry about flipping the inequality sign because I multiplied by a +3. And again, if I would like to graph this, I'm going to put 0, I'm going to count by 2's just to make sure that I can get that far out to -12. We're going to go close circle at -12, and the numbers that are larger than -12 are these numbers that are to the right. All right, let's get ready here for problem number 7, and this is the cable cost problem. It says your family has a cable television package that costs $40.99 per month. Pay-per-view movies cost $3.95 each. Your family budgets $55 per month for cable television costs. What are the possible number of pay-per-view movies that your family can afford each month? Well, I've already done some highlighting on this for us, and I highlighted the question in yellow. And that question is, what are the possible numbers of pay-per-view movies your family can afford each month? So the thing that we're trying to find here is the number of pay-per-view movies you can watch per, and I put MO period, that's an abbreviation for month, but it's the number of movies that you can watch per month. So what we have to do here is look at the information they gave us. It says that it costs us $40.99 per month. So whether or not we watch any movies or not, that there would be just a fixed amount that we have to pay. And then it says each pay-per-view movie is going to cost $3.99 each. What I need to recognize here is that this is a rate. So as I think about this situation, I start out the month having to pay $40.99, and then I'm going to add to that $3.95 multiplied by how many movies we have watched, which we don't really know the number of movies that we've watched. And that's going to be multiplied there then by X. And we need to make sure that we stay under budget. So we have to have less than or equal to an expense of $55. If we would like to continue solving here, what we need to do is we need to think about how we're going to go about solving this, which is going to be working to get X by itself. So I'm going to subtract $40.99, and I'm going to subtract $40.99. I'm going to be left with $3.95 times the unknown number of pay-per-view movies we're going to watch, and that is going to be less than or equal to, this is going to be $14 and a penny. What we're going to do here then is, sorry, that is a dollar sign. We're going to divide by $3.95. And we're going to get X is less than or equal to, I did have to grab my calculator here, but we're going to take $14 and a penny, and we're going to divide that by $3.95. When I divide that out, we're going to get, dollar signs cancel out, we're going to get 3.5468, keeps going on forever. Well, if we would like to stay under budget, it asks us, let's go back to the original question. How many pay-per-view movies can your family afford each month? Well, we're not going to really be able to watch 3.54, right? So if we'd like to stay under budget, we are going to come back and answer this question and say, your family can watch 3 pay-per-view movies per month or less. Maybe a better way to say that is your family can watch 3 or less pay-per-view movies per month. So again, if that would be maybe a better way to write this. feel like we're speaking better English, but your family can watch 3 or less pay-per-view movies per month. Another way you could write this is, I'm going to put or, your family can watch 0, 1, 2, 3 pay-per-view movies per month. I won't write the last one down, but we might also be able to say your family can watch a maximum of 3 pay-per-view movies per month. And again, the idea here is that 3 is that limiting point. Because the moment we would watch 4 movies in that month, we'd be over budget, which would mean that something else would have to be cut out of our budget, so that we are aware of that. And again, this here is a wrap on the